All right, advent of code, day 9. Here we go. With your neighbor happily enjoying your video game, you turn your attention to data port and little screen. Port is non-standard, connected to your computer. Data appears to be encrypted with the Exchange Masking Addition System. Xmas starts by transmitting a preamble of 25 numbers. Okay, we have 1,000 numbers here. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. Consider your preamble consists of numbers 1 through 25 in the random order. To be valid, the next number must be the sum of two of those numbers. 26 would be valid, 49 would be valid, 100 would be not valid. Suppose the 25th number is 45, and the first number, no longer an option, was 20. Was 20. Now for the next number, need valid some pair of numbers between here. Got it. Here's a longer list, which only considers the almost every number is the sum of two of the previous 5 numbers. The first step of attacking the weakness is to find the first number in the list that does not have this property. Cool. So in previous 25 equals int 0 24 puts that count. Cool. Int 25 1,000 10,000 dot each do next I dot sort. Let's see. For a in 0 through 24 do oh my gosh, 0 dot each do a 24 dot each do b. Next, if a equals b, I think, yeah. If found sum equals true or equals false. If a plus b equals next I. Oh, I don't want to sort these. Equals next I, then found sum equals true. Break if found sum. If not found sum, puts next I, exit. Let's just do that. Or I can break. And then oh. Prev a equals 25a, or b equals I j. And then we want to do a equals 1 2 3 a dot shift a. Okay, and so then we do prev 25 dot shift prev 25 next I. Dang, 345. Part 2, find a contiguous set of at least 2 numbers in which the sum, you must find a contiguous set of two numbers in your list. Part 1 equals nil. Part 1 equals next I. Part 1 equals next I. And now we want to do so we can basically start at start equals 0, end equals 0, sum equals 0, while loop do if sum is less than part 1, and plus, oh god, stop, sum plus equals, what are they called, ints, stop plus equal 1, ints stop, else else if sum is greater than part 1, start plus equal sum -1, start plus equals 1, but I don't want to, sum minus equal ints start if start greater than equals 0, else to find the encryption, add together the smallest and largest. Puts small start plus stop break. 51 stop. Let's wait. Oh, okay, this is a bad solution. While loop do sum equals 0, stop equals start plus 1, equals ints start plus ints start plus 1, oh, I'm doing this so poorly. While stop sum is less than equal part 1, sum plus equal ints stop, and if sum equals part 1, puts ints start plus ints stop break. All right, this is fine. Just a little n squared loop and stuff going on here. Oh man. This is going to take a while. Oh, I never increment start. What? That's not the right answer. Add together the the smallest and largest number in this range. Range equals ints start stop range.min plus range.max. No, 30 seconds. $25. This is killing me. Oh, I did so poorly. 14 seconds. I hope this is the answer. 8 seconds. 5, 4, 3, 2, 1. 6:34. Oh, so bad. So bad. Part 2. Part 1. What's up, Juiced Moose? Oh my God. 2 minutes and 54 seconds. Who are these people? Part 1. There we go. 4:37. I forgot to stop the timer again. I always do that. Not even close. Let's see how I did today. Yeah, terrible on this leaderboard. I had the slowest part 2 solution. Ugh, so bad. Dang it. All right, let's go back, read through the problem. Oops. Whoa, this is kind of cool. I don't really know what this is yet, though. Day 9, encoding error. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paper clips. Upon connection, the port outputs a series of numbers, your puzzle input. Data appears to be encrypted with the Exchange Masking Addition System, XMAS, which conveniently for you is an old cipher with an important weakness. XMAS starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any 2 of the 25 immediately previous numbers. The 2 numbers will have different values, and there might be more than one such pair. Let's open up my input again. So I get all my numbers. I get the first 25 numbers, and then the 2 numbers will have different values. So he goes through and explains that 26 would be valid, 49 would be valid, 100 would not be valid, 50 would not be valid, but the two numbers need to be different. So that's critically, they should actually be next if I equals j. Suppose the 26th number is 45 and the first number was 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 through 19, 21 through 25, or 45 that add up to it. Cool. Here's a larger example, which only considers the previous 5 numbers. What is the first number that does not have this property? So we have our list of 25, and then for every next value, we loop through the 25 values, all pairs of them, and get the values at those indexes. And if they sum, that's it. We break. We need to break out of the outer loop to, this should actually be here, but it doesn't matter. And then if we found the sum, that's, or if we did not find the sum, that was our answer. Otherwise, we get rid of the first element of the array and add the next element to the end of it. Cool. Then, yeah, so that's our answer. Part 2, final step in breaking the Xmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number from step 1. So to find the encryption weakness, you need to add together the smallest and largest number in this contiguous range. So this just does it real simple. This is just going to try every range starting from 0, then every range starting from 1. So our original start is 0. We get our sum. That's at least 2 things. This is kind of messy. And then while it's less than, while we haven't summed to the thing, we add another element. Then if we get to the value, we get our range, and then we print out the minimum value and the max value of that range added together. And then afterwards, we increment our starting value to try again. I try to do like a weird approach where like you have like you're extending your you have like 2 pointers, one to the start and one to the end, and like at first you're just extending the end pointer while things are too small, and then once it's too big you start incrementing the bottom pointer, which I guess should work. That's like the linear time solution, but these are small inputs. This is the simple solution and it works just fine. So let's see. Oh, dang it. Okay, I was gonna try to undo and then try to get my first approach working, but I just closed it. But let's actually try to see if that approach can work. 9/20/20 solution. Start equals 0, stop equals 0. Sum equals 0. Do while if sum is start is 0, sum is int 0. Yeah. If sum is less than part 1, else if sum is greater than part 1, else puts Let me just do the same thing. If the sum is less than part 1, then we want to do sum plus stop plus equal 1, int stop, sum minus equal int start plus equal 1, variant 2. Wow, I did it. Why couldn't I do that the first time? It went so quickly. Oh, that's what I was trying to do. It just didn't work. I don't know why it didn't work. I think because I didn't know how to handle the initial start, and so I like had start -1, and then like only do this if like start is less than something. Maybe I had a plus in here instead of a minus. Anyway, alternate solution. Alternate approach for part 2. Linear time solution. Okay. Add linear time solution to December 9th, 2020. All right, that's all for Advent of Code, day 9.